Welcome to this explainer, where we're going to journey into the completely hidden, awe-inspiring world of underwater volcanoes. If you just look out over the calm surface of the ocean, it's incredibly easy to assume that everything down beneath is just cold, dark, and still. But today, we're going to completely shatter that illusion. We're looking at the Earth's hidden engine. It's this fiery, violent, and surprisingly life-giving force that operates miles beneath the waves, entirely out of our daily sight, and it is literally shaping the world as we know it.
Okay, let's just kick things off with a stat that absolutely blew my mind. Scientists estimate that roughly 75% of all the magma expelled on Earth every single year comes from beneath the ocean. Think about that for a second. When we turn on the news, we see these spectacular, towering eruptions in Iceland or Hawaii or Italy, and we think, wow, we are seeing the planet's volcanic activity in action. But actually, we're only looking at a tiny 25% fraction of the whole picture. The vast, overwhelming majority of the Earth's molten blood is spilling out in total darkness right into the freezing depths of the abyss.
Notice the sheer contrast here. We typically picture volcanoes as these giant terrestrial mountains, right? Looming over cities and landscapes. But the invisible underwater ones, those are the true engines of our world. To put that into perspective, while terrestrial volcanoes might output around 1.5 cubic kilometers of magma per year, their submarine counterparts are pumping out 12 to 15 times more volume than that. They largely pop up where oceanic tectonic plates pull apart, like the Mid-Atlantic Ridge, and they are literally paving the ocean floor, creating brand new Earth crust every single day.
So, let's get into Section 1, Fire Beneath the Waves, the beautiful contradiction of our planet.
It honestly sounds like an impossibility at first, doesn't it? Water puts out fire. That's one of the very first things we learn as kids. Yet the ocean floor is dotted with thousands of active submarine volcanoes where these two opposing elements are just constantly colliding in this dramatic, endless battle. You might naturally wonder how on Earth a volcano can even operate under these crushing, freezing depths without the magma just instantly solidifying. The ocean down there is unimaginably cold, and the pressure, it's intense enough to crush a submarine. So how does a river of molten rock, burning at thousands of degrees, actually survive the exact moment it hits that freezing water?
Well, the incredible reality is that even the immense power of the ocean cannot fully conquer this heat. When the lava hits the seawater, sure, the extreme cold immediately freezes the very outer layer of the magma. It creates this hardened, rocky shell. But here's the trick. Rock is a fantastic insulator. So inside that freshly formed, pitch-black shell, the lava remains completely molten and incredibly hot. It just keeps flowing, pushing forward, and expanding that rocky crust like a giant glowing balloon. It swells and stretches until it finally pops, spilling out more liquid fire, only to instantly form a brand new shell. It's this mesmerizing, slow-motion process of continuous destruction and creation happening in absolute darkness.
Moving on to Section 2, Giants of the Deep. The discovery of the Tamu Massif.
This kind of fiery resilience leads us to discover literal monsters lurking in the abyss, specifically out in the northwestern Pacific Ocean. You see, when volcanoes erupt continuously over millions of years, without the massive erosive forces of surface weather to wear them down, they grow to a scale that almost defies human comprehension. Take the Tamu Massif, for example. Located about 1,600 kilometers east of Japan, this is the largest known volcano on Earth. It's a massive, extinct shield volcano hiding 2 kilometers below the ocean's surface. And it covers a staggering 260,000 square kilometers. Guys, that is roughly the size of the entire British Isles. It's 50 times larger than Mauna Loa in Hawaii, which is the biggest active volcano on land. But what's really wild is how impossibly flat it is. It towers 4.5 kilometers high from the seafloor, but its slopes have an incline of less than 1 degree. It's just a gentle, sprawling giant that went extinct about 145 million years ago.
Just to put this cosmic scale into perspective, geologists compare this earthly giant directly to the largest known volcano in our entire solar system. Professor William Sager, he's the geologist whose team actually confirmed the true nature of this massive structure. He stated that it belongs in the exact same league as Olympus Mons on Mars. Let that sink in. We literally have alien-scale geography hiding right here on our own seafloor.
Now, for a long time, scientists actually thought this massive plateau was just a cluster of multiple different volcanoes that happened to erupt near each other. We only know it's a single continuous mountain today because of some intense scientific detective work. Teams literally drilled deep into the ocean floor using the JOIDS resolution vessel, and they conducted massive seismic reflection surveys using sound waves from the Marcus Langseth research ship. And the seismic data proved conclusively that all that basalt rock covering this vast area, it flowed out from one single unified source. It was a massive paradigm shift in how we understand geology. Let's look at Section 3, the invisible danger, hazards hiding beneath the surface.
As awe-inspiring as they are, these underwater giants aren't just sleeping anomalies from the dinosaur age. When they are active, they create terrifying invisible hazards. We recently saw this modeled by mathematicians from the HSU University and the Institute of Applied Physics. Now, we all know about tsunamis, right? Massive surface waves that devastate coastlines. But while surface tsunamis are incredibly deadly, deep eruptions create immensely powerful internal waves beneath the surface of the ocean. These waves move a lot slower, maybe just a few tens of centimeters per second, but they carry devastating underwater force. In fact, these invisible deep-sea waves have been linked by researchers to the tragic, deeply mysterious sinkings of military submarines. The tragic loss of the American nuclear submarines USS Thresher in 1963 and USS Scorpion in 1968, as well as the Indonesian diesel submarine Nanggala 402 in 2021, are all suspected to be directly connected to the sudden, immense pressure shifts caused by these internal oceanic waves. The most terrifying characteristic of this invisible underwater force is that it acts sort of like a creeping, deep-sea ghost. Recent mathematical modeling shows a really sinister characteristic of these waves. If an underwater volcano erupts, the strongest internal wave doesn't hit immediately. It arrives with a significant delay. What this means is that a violent eruption could happen, the ocean surface could calm completely down, and then, long after the initial blast, a massive, silent internal wave could sweep through the depths, quietly destroying oil pipelines, sensitive underwater infrastructure, and passing submarines entirely without warning.
Let's dive into Section 4, Life in the Extreme, Ecosystems Born from Destruction.
Okay, so we've talked about the danger, but there is a miraculous flip side to this destruction. Where underwater volcanoes annihilate, they also act as nature's ultimate reset button, creating some highly bizarre life. Back in 2011, a submarine volcano, which was later named Tagoro, erupted just off the coast of El Hierro in the Canary Islands. It violently expelled magma and toxic chemical compounds for 5 long months. Total obliteration of the local seafloor occurred. It wiped out absolutely everything across 9 square kilometers, leaving behind what looked like a boiling, toxic desert of fresh basalt rock that seemed entirely hostile to anything living.
Yet, the total absence of sunlight and the heavy presence of those toxic volcanic gases actually set the stage for one of nature's greatest survival strategies, chemosynthesis. Up here on the surface, almost all life relies on photosynthesis, right? Getting energy from the sun. But down in the pitch-black abyss, organisms have evolved to extract energy directly from the toxic chemicals vomiting out of the Earth's crust, like hydrogen sulfide. It's completely wild.
And this perfectly demonstrates life's absolute resilience. Just 3 years after that devastating Tagora eruption, scientists sent down underwater drones to inspect the damage, expecting a wasteland. Actually, scratch that. It wasn't a dead zone at all. They found the fresh volcanic rock covered in something completely alien. They dubbed it Venus hair. These are white, filamentous, hair-like extremophile bacteria that form these dense, shimmering mats all over the fresh lava. The moment the water temperature dropped just below 100 degrees Celsius, these microbes moved right in. They thrive on the toxic hydrogen sulfide and use completely unknown, incredibly complex metabolic pathways just to survive and multiply. They are quite literally life built from poison and fire, thriving where absolutely nothing else should exist.
Which brings us to Section 5, Sculpting Our Planet, the Geochemical Reactors of Earth.
These deep-sea volcanic systems aren't just isolated freaks of nature. They are actively keeping our entire planet habitable. Surrounding these zones are hydrothermal vents, and they operate like giant planetary lungs and massive chemical reactors. Cold, dense ocean water seeps down through cracks in the seafloor, sometimes penetrating kilometers deep into the Earth's crust. Down there, the water gets superheated by the underlying magma chamber. That extreme heat alters the water chemically, making it highly reactive before it is violently expelled back up into the ocean in a continuous, vital cycle.
What we are really looking at here is a masterclass in chemical balancing. You might naturally think the ocean's chemical makeup is just static, but it's constantly being filtered by these volcanic rocks. As the seawater cycles through the hot crust, elements like magnesium and sulfates are physically stripped out of the water and permanently locked into the basalt rock. But at the exact same time, the vents pump vital trace elements, iron and sulfates back out into the ocean. By removing some minerals and adding others, underwater volcanoes actually keep the ocean's chemical makeup perfectly stable over millions of years. Without this continuous planetary filtration system running in the background, our oceans would eventually become endlessly toxic.
So, to summarize this massive hidden engine, these invisible behemoths pretty much do it all. They physically build the ground we stand on. I mean, places like Hawaii and Iceland only exist because submarine volcanoes slowly built themselves up until they eventually breach the surface. They filter and stabilize the exact chemical composition of our oceans, acting as a global thermostat. And through regulating the ocean, they indirectly regulate our entire global climate and atmospheric composition. And finally, they serve as biological sanctuaries, harboring alien life forms and completely sun-independent ecosystems that we are only just beginning to map and truly understand.
Ultimately, all of this leaves us with a profound mystery. We know that roughly 75% of our planet's volcanic power is entirely hidden from our eyes. We also know that humanity has mapped and explored barely 5% of the global ocean floor at a high resolution. So the next time you stand on the beach and stare out at the flat, seemingly calm ocean, we really have to ask ourselves, what other colossal, life-giving monsters, what other tumamassifs and alien ecosystems remain completely undiscovered right here on our own planet? Thanks for joining me on this explainer. Until next time, keep questioning what lies beneath the surface.